In the cold, far reaches of our solar system lies a world unlike any other. Titan, Saturn's largest moon, is shrouded in mystery and intrigue. As we explore the depths, we discover a hidden ocean, an underworld that bears the hallmarks of a world beyond Earth. With its thick, cold atmosphere and amazing surface features, Titan presents a unique landscape that harbors new terrestrial cultures. Here, in the lakes of methane and ethane, we explore groundbreaking ideas about the existence of the liquid ocean below the surface and the amazing forces that shape this planet. Titan captures our imagination with its unique characteristics. At about 3,200 miles across, it is not only Saturn's largest moon, but also the second largest in our solar system, surpassing only Jupiter's largest moon Ganymede. To put it this way, Titan is larger than Mercury, with a diameter of 3,032 miles. However, Titan's atmosphere sets it apart from its celestial brethren. Unlike all other moons in our solar system, Titan's thick, oxygen-rich atmosphere, thick and denser than Earth's, extends 300 miles above its surface. These conditions would cause Titan's average surface temperature to drop to over 310 degrees Fahrenheit. This cold environment is a result of its position in the solar system, which orbits Saturn and is more than 870 million miles from the Sun, more than 9 times the distance from the Earth and our star. These cold temperatures can cover the surface of Titan with water ice and methane hydrates, while allowing the existence of lakes and rivers containing water methane and ethane. Despite the differences in chemical composition and surface characteristics, Titan's surface looks quite intimidating to Earth. The Cassini-Huygens mission, which began in 1997 and ended in 2017, provided the first insight into Titan's surface. The Huygens probe, which landed on Titan in January 2005, was the first man-made probe to land on the Moon. The mission will last about 72 minutes and will send important data to the country before the severe cold. Cassini and Huygens observations revealed a surface filled with frozen lakes, rivers, and even volcanoes, reminiscent of Earth, but made of different materials. The Cassini mission discovered that Titan is decorated with large oceans of liquid methane, as well as small lakes and rivers, which come from methane rain. This cycle mirrors the water cycle on Earth. Methane evaporates, rises into the atmosphere and eventually falls to the surface, creating the spectacular lakes and rivers that mark the surface of Titan. The most compelling discoveries from the Cassini-Huygens mission are about Titan's interior structure. Radar measurements indicated the existence of a vast ocean of liquid water beneath an ice crust 50 miles thick. This groundbreaking hypothesis suggests that tidal forces from Saturn would generate heat, melting the surface ice sheets and creating a hidden ocean beneath the surface. But how can water survive in a state that challenges Titan's harsh conditions? Scientists believe that the bottom oceans contain about 10% ammonia, which acts as a natural icebreaker, reducing the water's hardness and keeping it hydrated even when there is a lot of ice. The high pressure that builds up inside Titan contributes to this unique environment, keeping the ocean in liquid form at temperatures that would freeze water on Earth. This hidden ocean connects to the surface of the Moon in surprising ways. The presence of liquid water beneath the icy crust suggests that the crust itself is more porous than previously thought, which could explain the unusual features observed on Titan. In addition, Titan can hear volcanic noise, eruptions that exhaust materials such as ammonia and ice instead of lava and ash, suggesting that subsurface oceans are the main source of these environmental conditions. The potential for life on Titan is an intriguing prospect that has intrigued scientists for years. The presence of a liquid ocean, along with the right chemical conditions, increases the likelihood that life will emerge in this alien environment. However, any hypothetical life forms would face extreme challenges, from frigid temperatures to constant methane rain, compounded by the high salt content of the ocean, comparable to that of Earth's Dead Sea. While the Dead Sea is known for its hostile conditions that inhibit higher life forms, it is not entirely devoid of life. Microorganisms have adapted to thrive in its briny depths, suggesting that if life does exist in Titan's ocean, it could take similarly resilient forms. Yet, the Cassini mission also revealed that the ice crust on Titan varies significantly in thickness, implying that the subsurface ocean may be slowly freezing over time. Should this process continue, it could lead to a complete solidification of the ocean, potentially extinguishing any nascent forms of life that may have arisen. As we ponder the mysteries of Titan, the quest for knowledge is far from over. Future missions, such as NASA's Dragonfly, are scheduled to launch in the coming years, aiming to explore Titan's surface in more detail. This innovative research rover can fly to different parts of Titan and study the atmosphere, surface and atmosphere. The discovery of Titan marks a new milestone in astronomy and planetary science. Each mission brings us closer to uncovering the secrets of this amazing moon, where the existence of liquid water and unique geological features combine to form a landscape that challenges our understanding of the world. As we continue to unravel the mysteries hidden beneath Titan's icy crust, we find ourselves on the verge of discovering whether we are alone in the universe, or alive, in some ways, in the shadow of our celestial companion. As a result, Titan is one of the most fascinating and complex objects in the solar system. The appearance of the deep ocean raises deep questions about the world beyond Earth, and as we continue to explore this fascinating moon, we are reminded of endless wonder of the world. The journey has just begun, and the revelations that await us about life, water and the nature of the universe may change. Titan's atmosphere is dominated by methane, which not only makes up the surface, but also plays an important role in the moon's activity. The lakes and rivers of methane create a dynamic landscape that changes over time, affected by extreme weather conditions produced by Titan's thick atmosphere. The presence of liquid methane also raises interesting questions about the chemical processes that mimic biological activity. Scientists hypothesize that, like water on Earth, methane on Titan may act as a solvent for chemical reactions, possibly leading to the formation of complex carbon molecules. These molecules could be clues to life or clues to past biological activity, prompting scientists to delve deeper into the moon's surface and subsurface environments. Looking at Titan and its many mysteries, the importance of continued exploration and research cannot be overstated. Dragonfly's upcoming mission will not only increase our understanding of Titan's environment and atmosphere, but also provide insight into its potential for life. By taking samples from different locations and analyzing the chemical composition of Titan's lakes and subsurface oceans, scientists hope to find signs of biological activity, terrestrial. The quest to understand Titan is representative of humanity's broader search for knowledge about the universe and our place in it. Each discovery pushes us into uncharted territory and reminds us that even in the cold and distant regions of the solar system, life and the mysteries of the world to push us forward.